Hi, my name is Benedikt Spielmann. I'm Product Manager for Digital Communication at GF Piping Systems. Today, I would like to give an overview how easy it is to set up an Ethernet network, including the necessary components to set up such a technology, and how it works in combination with our GF Piping Systems Ethernet-enabled actuators. In this example, we are focusing on Profinet, which is an open standard widely used across different industries and very successful in the market. So which components are necessary? Let's start here with the PLC. In this case, I've decided to use a Siemens PLC of the 1500 series, which is quite common in the market. This PLC comes directly with two Ethernet ports, which means it's directly possible to speak this Profinet language to the PLC. No additional interface cards needed. To set up an Ethernet network without analog sensors, it's even not needed to have input-output cards. Even they are connected here to the PLC, no devices are connected to those I/O cards. We can go directly with one Ethernet cable to the first Ethernet component. In this example, it's an Ethernet switch. In this example of the company Indusol. It's a great device and it offers a lot of functionalities in terms of cybersecurity, redundancy, and especially for troubleshooting the Profinet network. The switch offers different Ethernet ports again, which makes it very flexible to connect further Ethernet devices, either in a so-called star topology, which means I can connect different Ethernet devices to each port here. But Ethernet also offers the flexibility to connect several devices in a so-called line topology. Let's take a look at that. So we have an Ethernet connection here from the switch to the first device. In this case, it's our electric actuator, which is enabled to speak Profinet. From this device, we can go via the second Ethernet port to the next Ethernet device in this line. In this example, this is our positioner for pneumatic actuators. So as you can see, we offer here an Ethernet solution for both electric actuators and pneumatic actuators. Let's take a look on the interconnection itself. So all the green cables, which you can see here, are the so-called Ethernet cables, like this. This cable needs to be of category 5, but you also can use higher cable categories. In terms of connectors, there are two different possibilities. On the one hand, we have the typical known Ethernet connector, RJ45, which you might know from your office or home installation. This is typically used outside of the field level, so for switches and the PLC itself. On the field device level, it's much easier to use the other variant, the M12 decoded Ethernet connector, which makes it very easy to connect the devices directly from the outside without opening the housing. Those cables, those Ethernet cables, can have a maximum cable length of 100 meters, which makes it very flexible to set up different topologies. So we have 100 meter here, we have 100 meter on the next Ethernet cable, and so on. With Profinet, it's even possible to close the ring, so to create such a redundancy ring, which means going from the last device in the line, via the second port in this example, back to the Ethernet switch. This is a very important feature in terms of high availability of a process plant, because if one cable breaks in between of this line, this doesn't matter. The communication just goes the other way around. The last component which is needed to set up such an Ethernet network, it's the so-called device driver. In terms of Profinet, this device driver is called GSD, stands for General Station Description. You can download this GSD file via the GF website, but it's also possible to access this device driver directly from our electric actuator, because the device driver is stored here. So let's take a look how easy it is to access the web server itself. Let's take a look which capabilities are available in this web server. All I need for this is to connect to this local network, in this case by plugging in to the Ethernet switch here. I have some open ports and I need a normal laptop with a very simple web browser on it. Connect to the embedded web server. Enter the individual IP address of the electric actuator to a standard web browser. Roles and passwords prevent unauthorized access to the embedded web server. The administrator role
has write access to the parameter values. The system overview provides the most important live data from the electric actuator, such as the actual position, the motor current, and the total number of cycles. Static device information, such as the serial number, is also displayed in this overview. Diagnostic events are visualized by NE107 status, a clear description of the event, and the timestamp of the occurrence. Configuration of motor current and cycle time allows a process-specific monitoring. Factory reset, restart, and even firmware updates, everything possible without direct device access. The event workbook tracks up to 5,000 device events, which includes both diagnostic events and general events, such as parameter changes. The electric actuator provides static downloads, such as the user manual, the device driver for the PLC integration, but also generated reports with all parameter values, which can be used as documentation after commissioning. The event logbook is also part of this report. The embedded web server creates added value and is security certified according to IEC 62443.
So far, we have seen that we can reduce the number of I/O cards. We can reduce the cable effort significantly. But now let's take a look which additional data is now available with Industrial Ethernet. For this, let's take a look on the HMI. This is just an example, in this case of the company Siemens as well. This could also be any kind of SCADA system, but even any kind of cloud environment, because the data itself, it's transmitted from the device to the PLC, and from there you are open how to use it. So here, via the second port of the PLC, we have connected an HMI. Let's take a look which data is accessible. Besides the normal device functionalities like to open and to close the valve, with the Ethernet actuator, it's even possible to use the so-called positioner mode, which means I can bring the device to a certain percentage value between the open and closed position, often used for dosing applications, for example. In addition, we have the diagnostic capabilities of the device. So in this example, we are simulating that the manual hand wheel is inserted to the electric actuator. We can see this information directly in any kind of customer system, even in clear text. There's a lot of additional data available that can be transmitted from the device to the PLC. In this example, we can see the temperature, the motor current, and even the total cycles of the electric actuator over the lifetime. This data can be monitored over a certain time period, and by this you see easily if there's any abnormality of the motor current, for example, which means there is probably any issue with the connected valve.